bearing was added to the end of the lead screw to restrain vibration, to prevent oscillations, because it had some noise issues occasionally on some units. So the vendor, I think it was implemented in their factory in December, of adding a bearing to the end of the lead screw.
On the Y stage?
Yep. That's the only substantive change on the Y stage.
And what type of testing was done with respect to the system and the overall impact of that?
We had various systems, a number of, I think, what was it, so many go through our test process without any observed problems. And also through our standard IQC testing of the Y stage for performance without any issues. So
with the Z stage connected and imaging.
Well, that's in our manufacturing process. So when those stages went through manufacturing, yes, they were attached to the full system and had system level tests as well as the functional test with the Z stage on.
Okay, because part of my concern is that if there's more of an acceleration or a jerk component that's now prevalent in the Y stage, that could be exciting a higher resonant frequency in the Z stage that wasn't excited before.
Right.
You understand where I'm coming from? Obviously the Z stage is what gets looked at because that's directly correlated to the image. But if there's a contributing factor that's come in to exciting the Z stage that wasn't there before,
in what way would that excite the Z stage? I'm not quite getting the connection between a bearing that dampens vibration to adding increased high frequency noise to the Z stage.
It's not something that.
So James, are you referring?
That I can comment on over the phone. I'm trying to. I'm trying to understand all the variables first of all,
okay.
and what could be contributing to this.
Sure.
Right. And so where I can kind of see this going is that one of our engineers spent some time with you guys in Hayward, and we look at things with a vibrometer or some type of measuring instrument that monitors vibration and tries to characterize and understand this. But some of the variables that could go into the different tests that we want to perform is looking at the older configuration of the Y stage and the newer configuration of the Y stage, and trying to understand what might be going on in addition to just the Z stage.
Sure. We might want to move forward a little bit because we have more information which kind of diverts us from that path. The fact we have other observations, Anchor's made quite a few analyses of subsequent tests that I think would shed some light on this as well. So keep in mind what you have already. That's fine.
But one of the things that's important for me to know is that this type of data that you've got today that we're looking at on the screen right now, this slide, we can go back a year and a half, and 2 years and look at similar data and similar slides.
No.
No,
we don't archive our images. It takes up too much space because that would be, terabytes of data to look at that we never really use. So we do not have old images, even thumbnails.
And what percentage of units is this impacting? Do you have any feel for? Obviously, it started in February. It's down like 1 or 2, and now it's much higher.
I'd say 10 to 15%. But it's also, there may have been as many incidences of it because there's degrees of how much it affects our observations if we don't go look for the images. So we may have had somewhat lower metrics, but passing, right? And that may have been an effect, but we may not have gone and investigated since the system passed its metrics, so we may not have gone to the level of looking at images. And likely, if we didn't see those bumps on the intensity plot, because they don't always get that severe, we may not have noticed an unusual behavior on the intensity plots. Because I don't quite understand the phenotype of why those bumps are there of increasing intensity, unless it's the opposite, where those bumps actually represent the peak of those is normal behavior, and the rest of the profile is parts that have streaking. Like maybe those are the cycles that don't have streaking. So that's what haven't reconciled the mechanism of the why, right?
Okay. So
but,
when you talk about changing the metrics and kind of what you were looking at, did that come with the new software that came in March? I mean, are you guys
no, not at all.
looking at things in a little bit different way?
No. No, the new software did not change the specs at all. Did not change our performance. I'm trying to remember what the main changes. Oh, the chiller was one, right?
Yeah.
So some temperature controls of our fluidics, a few other things. What else did we have in March? The March release 2.2.
So how did
we
this
haven't
come
had
to
like a
be
chiller release at that time even.
noticed? What was the trigger point that this started to get noticed? Was it the image on the lower left, those which you monitor on every system?
It was probably
Occasionally
no.
started
It was
getting
probably
worse?
more fundamental than that. In that we failed some fit run or sequencing runs for performance metrics, and then in investigating the root cause on a couple of them, I remember distinctly doing this, noticing the streaking. When I tried to go and look at images to figure out why these two units may have failed. And then we saw that that was the case. And in doing so, we tried various things, and one of which was replacing the Z stage, which worked. And we put a new Z stage in, and the problem went away.
So when we replaced the Z stage, do we put back the first one that failed?
We have done that. Anchor's run some AB/AB tests on, what, 2 systems at least.
Right.
And made the observations correspond. It follows the Z stage.
So it follows the A would be bad, the B is
Yeah,
good.
so problem
You go
stays
back
with
to
the Z
A,
stage, yeah.
Right. Now James, I think we really do need to jump forward because there's some important information that I think relates to this that would kind of get us going.
Sure. Yeah. Yeah.
Do you want to go ahead, Anchor?
Lots of information.
Yeah. So, yeah, as we know that, only the red images during the autofocus skipping are affected. So, if we don't do the skip autofocus, maybe we don't see this issue. So, looks like there's something related to the street, like, to the settling time over here. Because normally when we do the bench test, like, maybe the PI is doing, and what we also doing, like, OP50. So when we move the, like, for the settling time from one position to the other position, I see some of the, like, a noise onto the graphs, and I compare those, graphs with the good Z stage, and I don't see any noise over there. So again, like when we see, like when I say, like, I observe like a minor noise over there, that doesn't mean that it failed for the settling time. It was able to pass the settling time specs and was able to reach, like, from like -10 to -40 microns and the other 2 specs. So no issues with the settling time specs, but somehow we're able to see some sort of, like, a noise, and maybe that noise is causing us some sort of, like, vibration, and that's why we are seeing, like, the images are, like, a little bit elongated in a y direction.
Okay. The second item I think is one of the key ones, though.
Oh, okay, yeah. So also, like, we saw that all the instrument that has a Y streaking issue, so the drag marks on the flow cell cover. So the way we installed the objective looks like during the 550 burn-in or the other operations at the instrument level, looks like the objective is rubbing against the flow cell cover.
So in other words, what that means is there's repeated movement. We don't do our objective height adjustments until after we do burn-in, and it appears that there have been cases that correlate directly to the Y streaking, where the objective, while it's attached to the Z stage and everything's functional, as we move in the Y axis on the Y stage, the objective is dragging along the flow cell cover with some minor amount of contact. and this is repeated for hundreds of cycles. Sure. So to go into this in more detail, we now have observations beyond 6. I think there's more like 10, 12, where every time we see the white streaking, we also see the drag marks on the flow cell cover assembly. So it appears that it's somehow we're inducing this by not having our height set correctly, or having software that is going too low and producing contact with the objective against the flow cell cover during movements in the Y stage. Right?
Okay.
I'm not sure of the why of the or the how of the mechanism. For instance, how does dragging the objective, its spring-loaded tip and a bit of, shouldn't be that sensitive. How is that causing future optical tests